Okay, so you can see the gap here, right, is increasing, right? The gap is different each time, and they look like the square numbers, don't they? Except they start as 0, okay? So these aren't the square numbers as we know it, in terms of 1 squared, 2 squared, 3 squared. They got 0 squared there as well. Okay, that's no good. When it comes to nth term, n starts at number 1, right? So you can't call this n squared, okay? You literally cannot call this n squared, because n squared then, where you start off the first term, which would be 1 squared, okay? And 1 squared is not 0, okay? So you can't call this n squared. What we'll do is, I'm going to write down the n squared sequence, and we'll maybe write it above, so it's clear. 1, 4, 9, 16, 25, 36, okay? And then you've got your sequence here, and then you've got to ask yourself, right, what am I doing here to n squared to get the sequence? Okay, well, to n squared here to get the sequence, I've got to take away 1. For n squared here to get the sequence, I've got to take away 3. N squared here to get the sequence, I've got to take away 5. I've got to take away 7. And then I've got to take away 9. You get the idea. Take away 11. So what you've got here then is a sequence in itself. Yeah? It's a sequence in itself where the gap, okay, if you look at the gap, is minus 2, isn't it? It's going down in minus 2. It's always going down minus 2. So this sequence here in itself will represent, because it's going down 2, you'd write minus 2n. And then you ask, right, what would the term be before it? The term before it, of course, would be 1, wouldn't it? We go up 2, would be 1. So this sort of part here represents minus 2n plus 1. We attach that then to the n squared. So you get n squared minus 2n plus 1. Okay? That's the sort of approach you could do there with that. Alright? Part E then, find the nth term here. Well, again, if you look at the gap here, right, the gap's changing. So with your n squared sequence, 1, 4, 9, 16, 25, 36, and so on. The sequence then, minus 9, minus 6, minus 1, 6, 15, 26. Now, what are we doing to n squared to get this? Well, we're taking away 10, aren't we? What are we doing here? Taking away 10. We're doing it, take away 10. That's nice, isn't it? So you're always taking away 10. So this would be n squared, take away 10. Okay? That's what you do to get the sequence out. Last part then. Here are the first 5 terms of a descending sequence of numbers. The nth term is given by that. Yeah, I think you'd agree, wouldn't you? It's minus 4n, because it's going down 4 and 130 with the term before it. So we've just written it the other way around. Without listing any further terms of the sequence, find the value of n that gives the first negative term. Okay? First negative term means that this here will become less than 0. Yeah? And we could keep going, but it does say without listing any terms. Okay? So we need to find the value of n. We need to show our working basically, because they don't want us to just list the terms. We need to show how we've got this. So what I say is, right, this, we want this. Okay, and I'll just say, look, we want this to be less than 0. We want it to be negative. And we can sort of solve this now. If we take that minus 4n over the other side, so it becomes plus 4n. And then just treat it like an equation, but keep this here. Take the 4 over and divide. Okay, 130 divided by 4. Well, half of 130 is 65. Half of that is 32.5. You got that. Now, when we read it like this way, it's quite hard to see. But if I reverse it round, so you know this arrow now is open wide, facing the n. So if I write it the other way around, you've got to make sure the arrow is facing wide to the n there. What that is saying is n has got to be greater than 32.5. Now n, remember, has got to be whole numbers. So it's got to be greater than 32.5. It's got to be 33. Okay, that's the first whole number after that.